Hi guys, Buildzoid here, and so I did the ASRock motherboard first impressions, so now we're gonna do ASUS. I expect much better things here than from the ASRock. Like, honestly, I was surprised how bad the ASRock Z490 boards were. Like, I was, just seeing the initial photos, I didn't really pay too much attention to, like, how many USB ports they had, primarily that. And I was like, oh, this doesn't look so bad, and then I went through motherboard, the ASRock Z490 lineup and was like, oh, okay. No. How about no? Just no. On the flip side, with Asus, I mean, I have much higher expectations here. Just initially, I think like so far what I've seen of the Asus motherboards, like I liked it, but I've not gone through every single board and made absolutely certain that there's like we're gonna see if there's any motherboards here that I'm like because currently I'm basically thinking of testing the Z490G because MATX is a the thing I like about MATX boards is that the boxes take up less space. so, so when I have those, they're easier to store around the place than the ATX boards are. Or even worse, like the ATX boards, like the high-end boards with the really nice packaging and everything, they're the worst. They take up the most space. That's an actual concern at this point. So I want to test the Dash G also because it looks like it shares a lot of its design with some of the other ATX boards. So it feels like I could test the Dash G and draw conclusions from that board that apply to a very large portion of Asus's motherboard lineup. So I have to do less work, and I get to test the most, like, it's also the most unique motherboard in that it's like MATX, and MATX is a very neglected form factor these days. And then what else do we have? Like, yeah, and then there's the Apex, which I'm buying because the Apex is just the Apex. It's like the super geared for extreme overclockers board, and I'm super excited for it. Like, I'm really quite annoyed that I never got a chance to mess with the Maximus 11 Apex. So with the 12, I want to see if I want to see what they managed to do with it. So anyway, let's get into it. Starting off, unfortunately, Asus's website, there's no way to really like reorganize it. Also, I will be referring to Newegg for pricing because, as far as I know, their pricing is actually accurate. And see, this is what I like. What I like about the Apex is because this doesn't have like the most high-end power stages, and there's some things where it looks like the Apex isn't like it doesn't look as extreme in terms of like raw hardware specs as say the Maximus 12 Extreme. But the thing I like it's a 6-layer PCB, whereas I think the 12 Extreme is like an 8-layer. The thing is, this is a 2-DIMM motherboard. You don't need that many layers to implement a very good 2-DIMM, whereas you need more layers if you want to implement a good 4-DIMM layout. So I don't really necessarily see like I actually like that Asus like the thing is because it's so geared towards extreme overclocking, they're kind of chopping off some of the excess expenses that you get on gaming boards. Ultimately, it's still expensive at $400, but at least it's not more expensive than the Hero, and it's definitely going to run circles around the Hero. I'd be very surprised if the Apex didn't run circles around the Hero in terms of overclocking. So yeah, I'm excited for the Apex board. But and I'm also excited for the rest of the lineup, but we'll see if there's anything that surprises me here. So let's just get into it. So Z490-E, ATX gaming motherboard featuring 16 power stages, AI garbage, Intel 2.5 gig, dual M.2 heat sinks, whatever. Just take a look. The 16 power stages, like, do they say what power stages? High quality. I guess if we scroll through, like they're saying it's a 14 plus 2 phase, 14 plus 2 power stage configuration, which 7-phase V-core, 2-phase, no, it's going to be like 7-phase V-core, 1-phase iGPU, I guess. Um, like that I have a problem with that. Asus, like the thing is, if you have a low phase count, there's just certain workarounds that you need to implement to compensate for it, and Asus is fully capable of doing that. So then it's just so I don't have a problem with what they're doing with a board like this. So, and I hate these overly interactive websites. Oh, no, yeah, I hate this. I absolutely hate these websites. It's like, why is it so animated? Just give me information. This is awful. Wait, so power digital, yeah, okay. Pro Cool 2. It's just a bloody power can. 8 and a 4 pin. Actually, 8 pin and 4 pin. On Z490, actually, if you're pushing a 10900K, you can max out an 8 pin power connector. So the extra 4 pin is very much necessary with the 10900K. Digi plus power control. Yeah, that's just what ASUS calls their power delivery. It's like a marketing thing. Everybody uses digital voltage controllers. ASUS just gets their manufacturers to rebrand the controllers with Digi Plus branding. So, though it actually looks like that has regular onsemi branding right there. At least, like I'm seeing what looks like an onsemi conductor logo on there. So, anyway, 14 plus 2, yeah. Alloy yeah. Like, this is all standard motherboard things. And they never mention the power stages. Okay, well, that's a bit of a disappointment. Storage and memory up to 4600. That's not the highest I've seen for Z490, but, you know, like, the thing is, this is doing 4600 on 2 DIMMs is way better. Also, since they're talking about reduced vias and crosstalk, I'm gonna assume that they're actually doing tabbed traces, and we can't see it, because that's like the main thing the tab traces are supposed to help with is crosstalk. And also, I'm pretty sure like everything is daisy chain now, which is part of why the funny thing is, like, daisy chain has a higher peak frequency than T topology, but T topology is, I guess, more consistent in terms of the frequencies you can hit. Or actually not really, because on 2 DIMMs T topology actually straight up suffers, whereas on 4 DIMMs T topology is like slightly better than a daisy chain doing 4 DIMMs. So yeah, it's just like, this is one of the things that ultimately you'd want to test. But 4600, it's not the highest I've seen for daisy chains on Z490. It's also like, I'm not sure how truthful the other Z490 daisy chain motherboards that are like, yeah, we can do 5 gigahertz on this, you know, how easy that 5 gigahertz actually is to do. You know, maybe ASUS is going like, definitely 4600 is possible, and, you know, that I feel has more weight to it than going like, with this very specific kit you can do 5G. It's like, well, what if I don't want to use that very specific kit? What then, right? Anyway, so moving on, you've got dual PC M.2s, undeniably ROG Strix. I don't care. Wait, is that the bloatware that comes in the BIOS? Whatever, like, motherboard software is terrible, so they don't say anything about the power stages, which is a shame. But the thing is, they do have like 14 of the damn things. So I'm gonna guess they're using like 60 or 50 like SIC. Like, they're probably gonna use the same power stages that they've used on like a TUF X5, like the X570 TUF, or the or even the like Maximus 11 Hero, right? Like, that's the thing, is like, they're not actually changing the power stage, they're just using more of them, which is fine. Like, that's the thing, is like, please use more power stages. Was basically my biggest problem with the Hero on Z390. So, you know, now we've got 14 power stages on even a Dash E motherboard. So, and the heat sinks, I mean, they look like I think those look decent. You know, and for like, the thing is, it's really hard to estimate heatsink effectiveness from pictures, because there's more to it than just having a lot of surface area. Because if you make a really dense heatsink, you can technically have a lot of surface area, but it'll also absolutely just stall any airflow trying to get through it. And, you know, so all of the surface area, like technically the fibers making up like you know, a ball of wool, right? A ball of wool has a ridiculous amount of surface area. It's not a good heatsink, though, and even if it was made of metal instead of whatever it is that wool is made out of, it wouldn't be a good heatsink, because air would just get trapped in it, even though it has a ton of surface area. So it's not just about surface area. There's also, you know, like, airflow considerations that go into it. And this looks like a heatsink that, you know, there's a decent amount of surface area. It's definitely very heavy. And the cuts they have made into it, like, they're pretty open, so air shouldn't have too much trouble actually, like, getting through the heatsink, right? That's obvious. Like, you know, it's great when you have all the surface area, but then the air doesn't actually go through it, and it's like, well, it's not doing anything then, is it? Like, if you've ever seen, you know, like, fully passive heatsink designs, you'll notice that they have very open sort of fin stacks. And the reason why they're so open is because if you make a dense fin stack and then expect it to work passively, it won't, because it just traps air because of how restrictive it is to airflow. So yeah, judging heat sinks is just impossible, impossible from photos. But this looks like it could definitely work well. At the same time, it might not even have to do that much work because there is 14 power stages under there, and even if they're like 50s, that is a substantial VRM. So like 50 amp power stages, that's still a very substantial VRM right there. I'm not seeing anything that's particularly like I'm mega impressed with. Oh, and they have BIOS flashback. That's nice. USB ports. Let's see in the specs if they give us anything more useful. 4 DIMMs. I wonder if we have a QVL for memory that I don't have to download. CPU memory support. Memory. Okay, nope. it's not working. I have to say, like, MSI's website is the best for looking up memory. Actually, MSI and ASRock do the best job of having, like, memory QVLs. For ASUS and I think Gigabyte as well, you need to straight up, like, download... Actually, I think it's only ASUS now that you need to download a PDF with all of the different memory kits they tested, which is just like, why don't you just have that on your website? Like, why do I need to download a PDF to read a bunch of text? Right? Can you not have text on your website? So, yeah, I'm not really seeing anything. Like, this just looks like a decent all-around motherboard. How much is it going to cost, though? Dash E, 300. Oh, I guess that's why it looks decent, doesn't it? Yeah, but it just looks like a solid motherboard. Actually, I think at this price point, it might be one of the more powerful VRM designs you can get. Anyway, let's move on to the Dash G, because that's the one I actually want to test. So, featuring 14 power stages. So, okay, so this one does actually have a slightly different VRM. But the Dash G is also like $240, so it's not the most expensive of, like, it's one of the cheaper Z490s out there. Not the, like, you know, I'd consider low-end Z490 being, like, below $200. And then you start getting the really nice motherboards around the $200 range, and then once you get up to, like, $300, that's when you get the fully featured boards. Wait, does the... Oh, they have a postcode on the Dash E. Yeah, see, that's what I mean when I say fully featured. Unfortunately, they've put the postcode in the wrong location, but at least it's there. Like, so at least we have the postcode where, like, on the board at all, because that is super helpful if you're overclocking. And around $300, like, there's no excuse to not have a postcode, in my opinion. So, yeah, it's nice. So let's take a look at the Dash G. So no postcode, but we do have the debug LEDs up there. Downgraded VRM with the 14 because it's a 12 plus 2. I assume if this has video outputs, then it has to, yeah, it has to have iGPU power. Otherwise, there wouldn't be an HDMI on the back. I don't like how they're like, you know, highlighting parts of the rear I/O, and then this photo is like you can barely see the rear I/O. Oh, they have BIOS flashback on this as well, so that's neat. What else do we have here? Power design. Will they tell us what we are? Nope. We have the metal shield, like the metal power connector. That's like the 4-pin's necessary. The metal, like the metal on the 8-pin, I don't know what the hell that's supposed to do. Metal armor for improved heat dissipation. The problem I have with this statement of metal armor for improved heat dissipation is, wouldn't the, like, ultimately, the thing that's, like, the connector itself is plastic, right? So the thing that gets hot inside the connector is the metal contacts between the power connector from your power supply and the motherboard. So the metal contacts, those get hot, and that heat then transfers to the plastic. And the concern is that the plastic gets so hot that it melts at some point. Like that's if you overload a power connector, the plastic melts, and you know that's no good. Because then if the plastic melts, the thing holding the connector together is gone, and now you have the potential for like the wires to get loose and short something out, and that would be very bad. But the thing is, like, so I can see the metal holding the plastic together. I don't see how the metal would sink heat faster than plastic, because it's not like the metal is adding any surface areas, right? Like, if we're looking at it from the perspective of like is the maybe the plastic is worse at shedding, like maybe the plastic to metal to air heat transfer is faster than plastic straight to air, but that doesn't really, like, my understanding of basic like thermal physics is you want less interfaces, not more. And the reason why on like a CPU you'll go, die, solder, IHS, thermal paste, heatsink, is because once you get to the heatsink, you have like 1,000 times as much surface area as the actual silicon of the CPU has, and so it makes sense to have the heatsink because it adds so much surface area, right? Whereas the die, there's too little surface area. So the goal is to get the heat into something with a lot of surface area, because that'll be able to get rid of the heat very quickly. But that metal casing on the connector looks to have about as much surface area as the connector itself. So I am not seeing how that would be like I don't know, but I guess I don't think it does anything. Um, I don't think it actually does anything. It does certainly. I don't think it hurts anything either, but I don't think it has any functional purpose. It's just kind of there. Um, anyway, 12 plus, and they still don't tell us what power stages they're using. Wait a minute. 1, 2, 3, because this is going to be VCCSA, and wait. Man, so with Z490, because Intel is so supportive of overclocking, you have so many different voltage rails that it's actually kind of hard to keep track of. So wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is, I'm going to assume, is like VCCSA. They have a 4 MOSFET VCCSA? That's insane. Like, I am very confused why that looks like the most substantial VCCSA phase I've seen. Or maybe they're just using really garbage MOSFETs. That's also an option. Well, no, but those are, like, VCCSA is not a high power rail. You shouldn't need 2 inductors and two. Yeah, I'm confused. This might have, like, maybe 2-phase VCCSA might help with overclocking a little bit for memory. But anyway, well, that's a very substantial VCCSA. Unless it's also like, it could also be VCCSA and VCCIO together, but it's like the MOSFET layout for that doesn't look like that's what it is. Because the MOSFET seem to be all going. Actually, that looks like a giant single phase with the layout that they're doing there, but it's really hard to tell. Anyway, we'll find out when I actually buy the board and test it, right? Like, but yeah, that's kind of interesting because I'd assume that's if that's giant VCCSA, then it would be the same as a lot of other boards where you have VCCIO, VCCIO down in this area, and then all of the other minor rails down in this area as well. But here it looks like they might have VCCIO and VCCSA over here, which is actually like that's a layout you'd see a lot on Z390 boards, but on Z490 generally IO and SA, like IO at least is down in this area. So yeah, that is interest, like that is a confusing layout. Also, it doesn't actually affect anything, but this extra capacitor over here is just like visually annoying. I don't like it where that cap is, because you have this lovely row of caps and this other lovely row of caps, and that's all nice and like symmetrical and pleasing to look at. And then there's this guy over here. It's like he's obviously, that cap's necessary. It wouldn't be there otherwise, but I feel like they should have like tried to, I don't know, like I don't like it just kind of sticks out. It doesn't affect anything, but I just think it looks weird. Anyway, so 12 plus 2. Also, it's interesting that they're leaving out some of the multi-layer ceramics. I guess when I get the board, I can mess around with like adding those back on. We'll get like, I'll get a successor to my Z390 gene out of this board. Swap all the inductors, add a bunch of capacitors, and go like, oh yeah, I reduced the overshoot by I think 30 millivolts or something, which is like, it doesn't actually affect anything at that point, but whatever. And then yeah, standard alloy choke capacitor marketing from ASUS. Storage and memory, don't really care. Yeah, see, this is going to be the same memory layout as the Z490E, right? Which this is the reason, like, and this is one of the things is like, if you're not going to be buying a 10900K, and even if you're going to be 10900K, I feel like I'd be pretty confident with this power delivery for a 10900K and the heat sinks that this comes with. But like, even on like a relatively, you know, cheap board, you're getting the same like really good memory overclocking support. So yeah, like that's why I don't want to really go and test something like the Dash E, because it's like I think I can draw most of the conclusions for the entire lineup from the Dash G. Anyway, and also I just think like MATX is cool. Takes up less space on the desk when testing it too. That's another benefit. Dual M.2, okay. Wait, what do they have with DIY? Pre-mounted I/O shield. Okay. Wait, if I just scroll through it, does it go through? Oh, it doesn't go through all the same stuff. Wait a minute. Did I miss something in the power cooling? Oh. Oh, I guess they're just highlighting the different VRM. Okay, they have a thermal pack. Yeah, you have a heatsink, of course. Okay, I actually don't care that much. Scroll down. Why did that play? Oh, well, whatever. Actually, why did that make a sound? Oh, I'll look into that later. Anyway, so what else do we have? 5-way optimization, random motherboard software. Yeah. So this is the kind of thing that you just have to test. Digi plus power control. Like, it's neat that they give you access to the VRM controls in Windows. At the same time, the last time, like, AI Suite was last good on, like, DDR3 platforms. Because, like, since then, the various motherboard vendors, like, overclocking, like, motherboard utility software for Windows has been just getting steadily more and more bloated, and I really don't like it. So, yeah. Anyway, let's go over here. Z490i. So this is a $300 ITX board. It's one of the most expensive ITX motherboards for Z490. Not that they're significantly, like, there's not many significantly cheaper options. Gigabyte and MSI both have, like, their Gigabyte, MSI, and ASRock are both around all around $270. And those boards also look really, really solid. So I'm very interested in testing them out, mostly because of the memory overclocking potential, not because I actually care about small form factor systems. It's just like ITX is great for memory because you only have 2 DIMM slots. And that gives you a major overclocking advantage. So anyway, let's scroll through here. I'm not going to be testing this mostly because it's $300 and there's other ITX boards I'll be testing. I'm not really a fan of having the debug LEDs, where is it, like mashed between the 24 pin over there. They have a fan hiding in the I/O cover, so if you're looking at this and going like, oh, there's no VRM heatsink, I assume what they're doing here is they have a fan, and then there's a fin stack that they're exhausting air probably through like this area down here, and maybe out the top as well. It's kind of hard to tell. Let's see if there's better photos of that. No, there isn't. We can't really see into that area. But I feel like if you have that fan and that, I'd have assumed like, well, I think it would have been good to have that top area somewhat open. It looks like it's pretty closed off though. But then down towards the bottom, we have that, you know, hole over here. Like, it looks like a hole. So I'm going to assume that it's going to exhaust like VRM heat down there. And at the same time, it's like, how is this VR? So they have like what looks like 4 inductors over there. Then most of the actual VRM is up top. Actually, no, there's probably 2 more inductors hiding in there. Because I think this is an 8-phase. Let's go back to the overview. 8 plus 2. Okay, wait, what? 4 plus 2 phase? Really? Because, okay, well, I don't think ASUS would use an actual intersil voltage controller. Like, I can't think of an intersil, any ASUS anything with an intersil controller now that I think of it. And I'm not sure. Maybe there's some other manufacturer doing a 10-phase controller. Actually, like International Rectiv, no, not IR. Infineon has a 10-phase, which might be under IR branding anyway. But yeah, I'm not sure. Like the thing is, even if it was a 4+2 phase, like Asus knows how to compensate for the low phase count really well because they've been doing it for ages. Um, Yeah, actually, you can see it pretty clearly right there. So I'm guessing they're using an ASP 1405 here because one, two, three, yeah. So they have four phases over here. I mean, two phases down here. Then they have another. Yeah, so they're gonna have like iGPU, two more phases of vCore, two-phase VCCSA again. Here, I would really assume this is VCCSA and VCCIO, right? Like, because there's not that much space to just have a two-phase VCCSA, unless they really think, like, that is very, like, I really wonder about that. The thing is, they're saying 8+2 at the same time. DR MOS, those look like smart power stages. I wouldn't. Well, I guess technically they're driver MOSFETs as well, but I feel like lumping smart power stages with the other DRMOS parts is kind of not fair to the smart power stages. They are a lot better than the regular DRMOS parts, and that is the 5x6mm package that you get your smart power stages in. So yeah, I wish they would give us an indication of how much current they're supposed to be able to handle on their own website, because the thing is, like, most of the review sites mention it anyway these days, like what current handling spec you have. I'm gonna assume they're 90s mostly because like MSI, ASRock, Gigabyte, they all use 90s on their ITX boards. um, and even then, like, the funny thing is the difference between the 90s and the 70 amp smart power stages, it's not that much. So like, even if this was on 70s, I wouldn't actually care. So yeah. Um, let's look at the rear I/O. That actually looks solid for an ITX board. Like, it doesn't have as few USB ports as it could. So yeah, the thing for me is, like, this looks like a solid ITX board. I just don't see anything that's like super standout to me, and it's also $300. So it's not even like, it's not, it's not as cheap as some of the other ITX boards. It doesn't look any really better than the other ITX boards, not to me at least. There might be some feature I'm missing. Um, yeah, but it's same Intel 2.5 gig that everybody else uses, Wi-Fi 6, which everybody else uses. Actually, I think MSI might be 2.5 gig Realtek, but um, like, at least Gigabyte I think uses Intel. Um, 4800. The thing I'm surprised that they're not saying this board can do 5000 because it is a two dimmer. Yeah, so you have the little fan hiding in there. Oops, hit the mic. Yeah, I'm not really, like, it looks like it should be a solid board. It doesn't just seem like, I'm not seeing anything that has me like super impressed. Oops. Well, let's take a look at the Z490-A gaming. 250 bucks. And the Asus website is okay. There we go. 14 power stages. Yeah, so this is the same VRM as the Dash G, right? Whoop, yep, 14 power stages. I assume it has yep, that's HDMI and DisplayPort on the rear, so it has to have an iGPU phase, at least one. And actually, they tell us straight up 12+2, so there. Looks like it has less capacity. Wait. And, okay, no, I think they just shuffled the capacitors around a bit, so it looks different, but Anyway, scrolling through. Oh, they shuffled the VCCSA VRM away, I guess. Yeah, like VCCSA isn't up there anymore. It's down here now. Let's see if they have anything special. Cooling, not really. VRM. Yeah, it's a VRM heatsink, whatever. 4600, same thing. Like, this just looks like a solid $250 motherboard. I'm not seeing anything particularly concerned with, like, I wish it maybe had a postcode, but, you know, we still have the basic debug LEDs over there, and the rear I/O isn't too bad, I'm assuming, right? Yes, well, no, it's not as bad as it could be. I guess after seeing Z490 ASRock boards, my standards have been lowered significantly for USB port demands. I still feel like they should have given us, like this should have had a full stack somewhere, like 4 USB ports just stacked up, instead of just the 2-port towers. Um, but yeah, I'm not seeing anything that's like concern worthy. At $250, it might not be the most cost effective option, but I assume a lot of people will be going for that board mostly because it's like silver. I do not consider that white. Whereas everybody, like, this is one of the things I don't like about RGB is just like all of the motherboards are now black or white, and there's no color anymore. And so it's like you're either gonna have a black board or you're gonna have a white board, and that's your choices. You can't have a blue board or a green board or a red board. No, black and white. Though actually no, the dash H from ASUS does give us a dash of red. I wish they had gone heavier with the red, because I really miss the old black and red ROG boards. And it's just like we don't get those anymore. Everything's just black or gray. Anyway, does this look decent? Well, yeah, this looks like the same VRM as the Dash G, and it's also about the same price as the Dash G. Yeah, this actually looks like the Dash A minus, I guess they removed something, so anyway, I'm not really going through this in order, am I? Wait, because I just scrolled down to a board I was interested in, but wait, G, oh, this is the G with Wi-Fi. Wait, is this the Wi-Fi version? Oh, cool, so I might be able to get a Dash G for even less once they offer the non-Wi-Fi version. Perfect, because it's not like I'm going to be testing Wi-Fi 6. Dash F. What's the Dash F for? It's 270. Okay, so actually I need to have the Dash A and the Dash F open at the same time so that I have some idea of what they're changing. I think this just gets a better VRM, right? No, this is still the same VRM as the Dash A. Did they add the heat pipe? I guess they added a heat. Yeah, it looks like they added a heat pipe. I don't think I'd pay $10 for a heat pipe. Rear I/O looks the same. VRM looks the same. What did they change? Memory is the same. Yeah, this looks like the same board. Wait, so Intel 2.5 gig, because they had to have changed something, right? No, this is also Intel 2.5 gig. Is there a postcode or something? Like, what? Why does... I don't get it. It's the same board in slightly different colors, and I guess you're paying, like, I guess the black paint costs extra. And also there's the heat pipe. Yeah, so if we zoom in on this and zoom in on this, it's the same. Oh, I guess they reshuffled, like, this PCIe is new. So I guess they're giving you a slightly different PCIe slot like layout. But other than that, it's the same board. So I guess, you know, if you're considering, like, if you like the look of the Dash F and you're going like, oh yeah, I'm gonna buy a Z490 Dash F, strongly consider the Dash A, because, or actually maybe not, because they're $10 apart. There's not really like, I guess you could spend $10 more on your memory, and that's ultimately going to make a bigger difference, or $10 more on your cooling system, or like that's the thing, is like every X dollars you save on your motherboard is money you can put towards something, like towards something else. And if as long as your motherboard is still good at memory overclocking, right, you can just keep dumping more and more budget into the memory kit to get slightly more CPU performance after you've maxed out, say, your CPU cooling system. At the same time, I wouldn't go for like a crazy CPU cooling system at the cost of having a trash memory kit, because sure, now your CPU is really fast, except it's constantly stalled out waiting for data from the RAM, right? So there's a sort of a balance to strike, but yeah, like the thing is, the motherboard just kind of connects things together. So it's like if it doesn't have more connectors, if it doesn't have, features you want, that like any extra features you want, why pay for it? That's my main question. And like this, it adds a heat pipe. I don't think that heat pipe does much of anything for the overall thermals, or if it does do, like it probably, like that heat pipe isn't likely to drastically change the thermal performance of the VRM. So I don't really see a reason to like worry too much about getting the heat pipe. I wonder if they have, oh, I guess they show an accessory pack. Man, why do they have this stupid zoom setup? Like there's enough space on this screen to have all of the like the little thumbnails available down there. Even the accessory pack looks very similar. So yeah, I'm confused. But anyway, so that's the Dash F. I guess let's get to the Z490 Plus Tough. Okay, so same VRM as the, yeah, that's still the, oh, they've reshuffled the VCCSA VRM away again. Wait, this is wait, what? No, it isn't. Okay, wait, let's just scroll down. Oh boy. Okay, well, let's just check the price for the Tough. So, Tough Wi-Fi, $200. So this is one of the, like, $200 I feel like is the sweet spot with Z490, where you get like really nice boards from a variety of different manufacturers, depending. So, basically what you do is you go to $200 and then you compare the different feature sets. These heatsinks look like they have a lot of surface area, so I like that. And the rear I/O, oh man, that's not a lot of USB ports. I am not a fan of that. The thing is like in my personal system, I have a lot of USB ports used up. So it's like seeing a motherboard with not many USB ports is like, I also, like most people don't need, I guess like most people just have like a keyboard, mouse, maybe a printer, maybe a webcam. And that's like 4 USB ports. Except I've got a printer, two webcams, then like a USB sound card. Like basically, I just hog USB ports like crazy. So obviously, my needs as far as USB ports go are not very realistic. But the thing is, I don't feel like USB ports are one of the things that should add significant cost to motherboard manufacturing. Like I've not actually asked how much extra, 2 extra USB ports cost for a motherboard maker, but like it is one of those things that I do care about a lot, having a lot of USB ports. So not really a fan of the fact that this doesn't have that many. Why is the website so slow? This looks VRM-wise to be basically the Dash G VRM with like some capacitors removed. So I guess the transient response on this is going to be ever so slightly worse. Probably in the overshoot direction. Actually, they've really, like, if we scroll down. Oh, also what's neat, this still uses the 6-layer PCB. But that's the thing, like a lot of the motherboard vendors at $200 are using 6-layer PCBs. So this is why, like, like basically going from like $200 all the way up until like $350. With a lot of the different manufacturers, you're going to get the exact same memory overclocking performance because they're using they're still using a 6-layer PCB for every single one of those boards in that price range, and so they can take the memory topology of a $350 board and just stick it onto a $200 board, because that's just like the only requirement for doing that is like, do you have a 6-layer PCB? Right, if you have a 6-layer PCB, you can do a 6-layer memory topology, and so you can use a memory design that goes all the way up to like a $350 board, and so you don't see like huge differences in terms of memory overclocking capabilities. Right, this is a 400. This does 4600, and then if we go up to like the Dash E, if I remember correctly, was also up to 4600 because it's also a 6-layer PCB using probably the exact same daisy chain. So, you know, like the other benefit to that is of course, if they're doing like BIOS optimizations for memory overclocking, then a memory overclock, like they can do essentially one BIOS update and it works on all of the boards, because the topology, like all of the boards sharing the same topology, it'll have the same positive effect. So like there's a bunch of reasons why you don't see like a lot of like that's why you don't see a lot of variety there, right? Like if we go through this, yeah, 4600, see, and this is a $300 board. So you can save 100, like if you don't need some of the features that this offers, you can drop down $100 and you still get the same exact memory overclocking performance that you'd get at $300, which is just kind of neat in my opinion. Then we have the solid pin power connectors. This is standard for like Asus and Gigabyte both use these on the regular. And this does help. So the regular, like the traditional, yeah, is max 384, EAT, and then you have the solid pins, which, so this 480 watt rating, I think, is only if you're using 18 gauge power supply. Wait, 18? Yeah, 18 gauge power supply cables. But there are some power supplies that actually use 16 gauge for the 8-pin power connectors. And then these solid pin, like I think the solid pin power connector that ends up with a power rating that's a little over 600 watts. Obviously, if your power supply doesn't use 16 gauge cables, that doesn't really help you. And there's also a concern with the power connectors where just because you have an 8-pin, like there are some PSUs that'll have a 6-pin connector on the PSU end going into an 8-pin on the motherboard end. So your motherboard might be fine, but the PSU end of the operation might actually be out of spec by, 33%. So that's one of the concerns with like one of the benefits of having an 8+4-pin configuration is if you have a not so like if your power supply, like, because they do it even on I think some high-end power supplies where you have 6-pin to 8-pin power connectors. Going from the power supply end to the motherboard. So there you can go and use two, so like essentially on the motherboard end you'll have I think 10. No, yeah. You'll have 10, yeah, because you'll have 6 from your first 8-pin, and then you'll have like 4 pins on your second, on your 4-pin. So you'll have 4 plus 6 at the power supply, and that should be able to handle plenty of power. But yeah, it's just one of those weird design decisions that you see in PSUs, in my opinion. But I mean, like, seeing it is not in my opinion. Like, it's a weird decision in my opinion. Because it's like the power supply, if anything, should not be, should not have a weaker power connector than the thing that it's powering, right? Like, that should not be a concern. Anyway, so what else do we have? System stability. We have tough components, which is just marketing stuff. Digi plus VRM marketing stuff. That's just a standard digital controller. We see those everywhere these days. Tough gaming alliance, tough protection. So you have armor on your PCIe slots. Yeah. Easy configuration, whatever. Actually, what safe slot, ESD, the DRAM over voltage protection, onboard resettable fuses prevent overcurrent and. Wait a minute. For the memory? Why would you need fuses on the memory? I am very confused. Also, Oh, they don't have the VRM naked pictures. I'm not just imagining that. I'm actually not seeing them. Yeah, okay, no naked VRM pictures. Not like they would tell us what power stages they're using, but I'm gonna assume like it's gonna be the same as what you get on the Dash G. Which is another reason, like I can test the Dash G, and if that doesn't run very hot, then I can make the safe assumption that the Tough doesn't run very hot either, and you get to save another $40 there. Um, so that's pretty neat. Like the main problem I have with this board is the USB ports, but other than that, it looks like a solid motherboard at $200. But there's a lot of solid motherboards at $200, and some of them have much more USB ports. So, you know, depending on your priorities, you might want to consider one of those instead. Anyway, next we have the Z490M Plus. So, like a low-cost MATX option, which 8+1. That's going to be 4+1 in terms of actual phases. 6-layer PCB. That's actually surprising that they're still using a 6-layer PCB this low. I guess the idea, but 4400. So I wonder what they changed with the memory that it's clocking worse. Because if they're like, I would have assumed that this would still be on the same topology, but I guess they changed. Well, there is 2 capacitors here, and there's only 1 there. But I don't know. They've just removed one, so it. Well, okay. Well, apparently that maybe it's like power delivery for the memory that they've tweaked or something, because I don't think the actual. But then again, like DDR4 just does like I don't think power delivery for DDR4 makes that much of an impact. But yeah, that's interesting that they're saying only 4400. Because I'd expect it to still do 4600 if they're still using a 6-layer PCB. USB port situation is not great, but that was already the case on the Tough. Heatsinks look like they're designed to actually run passive with a halfway decent amount of surface area. This motherboard's not really designed for like, you know, overclocking a 10900K. This is really meant more for like a 10700K, 10600K. So I don't really see a problem with the way this looks. And yeah, for a 10700K, this would actually like be. Actually, wait a minute. I think I recognize this heatsink. That looks a hell of a lot like the heatsink they had on the Z490-A. And that also used a, you know, 8 power stage VRM. And those were 45s, so maybe they bumped up the power stages for this thing. But the Z390-A definitely, like with a 9900K, you could get the VRM to overheat quite easily. Like it wasn't really that difficult to do that. So I guess this is really meant for like a 10600K. And if you want to run a 10900K on this, you'd probably want to like zip tie a fan to the VRM heatsinks, because otherwise, yeah, it's gonna this will get very hot. So, but overall, like that's like the thing is, this isn't meant for overclocking really. So, you know, and that is also a $150 board. So for the 6 core, it's it should be a very solid, should be a solid option. And then if you just zip tie a fan to the VRM, and you can get, you know, a 40, 50 millimeter fan really cheap for like $5, or if you just set up your case airflow weird where you have like top air intake, right? Because normally everybody has top air exhaust, and the thing about top air exhaust is that fans, when you're pulling air into a fan, the fan doesn't concentrate the flow of the air very much doing that. So you essentially, like, unless you have a metal, like, unless your heatsink is like a metal mesh going over the fan is not going to be pulling air through the heatsink. Okay? Like, if there's any lower restriction available air, it'll pull that instead of whatever hot air is coming off of your heatsink. So that's one of the things is just like fans are not that great in a pull configuration when it comes to cooling, especially if you're not like restricting where they can pull their air from. Like unless you're going to have like a fan shroud that, you know, forces all of the air to that the fan is exhausting to go over the VRM heatsink. It's like an exhaust fan sitting like above the motherboard is just not going to do that much for thermals. So you really would need to have a top air intake, which is kind of weird. Like that's not a very common way of setting up your airflow in your case, and that's why, you know, if you don't want to run top air intake, you need to put a fan on the VRM, because otherwise you're just not actually going to be guaranteed any amount of airflow over the VRM. Also, I assume they're just copy pasting this VRM design from the Z390 boards, and that VRM design does not have software accessible temperature monitoring. So the fun thing with this VRM is it does have working over like on Z390 it had working over temperature protection, as in if it gets too hot it'll shut down, and I know this works because that happened to me while I was testing the board. While I was testing a Z390 ASUS board, it actually just straight up shut down on me, and I was like, oh, okay, I guess that proves that the OTP is functional. Didn't do that anymore after I threw a fan on it, but yeah, I would assume that this is like I guess if you're, you know, hammering a 8-core or a 10-core overclock on this and the board randomly shuts down on you while running a stress test, you've overheated the VRM. That's all there really is to that. But yeah, for $150, this is a really, like, it looks like a solid board. Like, I don't really have a problem with it. Because especially, like, it's not like, you know, it costs money to build a bigger VRM. Yeah, not, like, it could be worse. It could be a lot worse at that price point. What else do we have? So that was the M, then we have the non-Wi-Fi plus, then we have the Dash H. Ooh, the one with the red dash. So that one makes me excited because it's the most colorful motherboard. So, you know, we're still seeing the same VRM as on like the Dash G, just slightly relayed out because they've moved the VCCSA down here instead of having it over here, which doesn't really, like, that's not a big deal in my opinion. Memory overclocking, I'm gonna assume is still the same. Okay, no, that's networking, storage, and memory. 4600, yeah, it's still the same. How's the USB port situation? Load, damn it. Actually, I guess, because this is 20 bucks more than the Tough. I guess you lose the Wi-Fi, but if you don't want the Wi-Fi, I feel like this might be a... Actually, the USB port situation on this is still terrible. I was kind of hoping that would be a lot better, but nope. You do have two... Well, I didn't really watch for those, so... No, like, okay, so you have only one internal USB 3.0 over here, but you have two on this board. So, yeah, this one, like... Oh man, what is with those SATA ports? Like, there's still 6 of them, but they're just, like, flat. Like, you don't normally see them laid out like that. Anyway, so I guess, you know, if you're ready to spend extra, well, if you have a lot of front panel USB ports, or if you're willing to buy one of those, like, PCIe slot USB port brackets, you can use this board, and it'll give you a lot of USB ports. I'm not really seeing anything hardware-wise that's like, oh, this is terrible, or this is amazing. But yeah, moving on. So that's the Dash H Maximus 12 formula. So this board, initially I would have written, like, initially I've written this off as having a water block on the VRM, and that's really stupid. And it is really stupid, but what isn't stupid is this has 10 gigabit Ethernet. Which is kind of a really neat feature, because at around, well, like at around $500, you don't, like, I'm not aware of other, like, non-ASUS motherboards with 10 gigabit. So I think that's really cool that they have that. And then, of course, you get the full, like, it's a proper Maximus board, so you've got all the overclocking stuff. Right, you've got the 16 power stage VRM. I'm trying to see if they have anything. Yeah, like clear CMOS, BIOS flashback. You've got a bunch of USB ports, 10 gig, 2.5 gig, like Wi-Fi 6. Like, yeah, this is actually nice. I wish they had a cheaper option for this. Like, there was a cheaper version of this board without the stupid water block. But hey, like, you know, if you can live with paying for the water block, that's cool. It's a cool board. Let's see. Yeah. We know Asus doesn't like. You don't like paying for power for doublers or capacitors. Or more like Asus likes paying for extra capacitors on the input side of the VRM and not on the output. That's really the main thing that's like a significant difference if you compare Asus VRMs to like a lot of other vendors. Is just like their input filter is ridiculous to compensate for the lower phase counts. High quality components. 70 amp power stage is nice. Don't really care about any of the other stuff that they're talking about there. Memory, Optimum 3, 3600 plus kits. Yeah, I was kind of hoping you'd tell me how many layers you're using. Because that's the question to me, is like, is this a 6 layer or an 8 layer? Accurate voltage, yeah, so they have the CPU die sense voltage readings, and they're replicating to the Super IO as well as, the thing is, that's not digital. Like, that's an op amp. It literally just copy pastes the analog voltage level from the CPU die sense to the like to the voltage input, voltage sense inputs of the Super IO. So I like this. Like, it's a cool feature. This graphic is just kind of not so great. Like, this part's digital. The part where the Super IO talks to the software, that's digital. The part where the DiSense gets the voltage from the CPU DiSense, like the DiSense, like the op amp replicates the DiSense voltage to the Super IO. It's not digital. There's no ones and zeros involved in that. So, yeah, it's just like it's fine. It's fine though. So yeah, this graphic is a bit misleading, but ultimately it's a cool feature. I appreciate it because like the thing is, it makes sure like basically now you can actually like with the ASUS boards you can go into CPU-Z and you can look at the CPU-Z voltage reading and it's not wrong because without this it's wrong because it's measuring on the back of the socket and yeah, that's not great. Also, this is one of the boards that has the little tantalum capacitors jammed into the socket, or they might be SMD polymers. Like either way, they have like bulk, like some form of molded polymer capacitor in the socket because you can get them both in aluminum. You can also get them. Actually, I'm not sure that package size is available in aluminum, but yeah, you can get tantalums and aluminums in that style of packaging, and so it's kind of neat that they have those jammed into the socket. And apparently, they also have them on the back. Oh, and this is rated for 4800, so I'm going to assume this is on an 8-layer PCB because otherwise it would probably do the same 4600 that everything else does. Um, yeah, 4800. So I'm going to assume this is an 8-layer. So yeah, this is honestly like I like this formula. As much as I didn't like some of the past formulas, I do like this one. This is, you've got 10 gig, you've got your 2.5 gig, so you've got really nice networking. You've got all of the overclocking features. Like the VRM water block is dumb, but that's always dumb. And at least they're not charging like not like it's $500. I can kind of accept that, I guess. Um, oh, also, isn't that center thing like an OLED screen, like the formula part right there? Either way, I don't care about that. So yeah, I think this is actually like compared to its predecessor, this is a really cool formula. Like compared to say the X570 formula or the uh, Z390 formula, I really like this, especially compared to the Z390 formula. I really like what they've done with this one. Um, Not gonna test it though; it's way too damn expensive. But I do like what they're doing with it. Like this is what a freaking formula board should be about. Like I mean, I don't care for the water block, but that the thing is like the VRM water blocks on formula boards have been like I think they did it on like a Maximus or Crosshair. Like it's a really old feature that they've been doing. So it's like part of just getting the formula. Like I can understand having the water block for heritage reasons. Okay, even if it doesn't functionally achieve anything. Uh, or at least like it'll still make your VRM run cooler. It's just like your VRM probably doesn't need to run any cooler considering what it's made of. Um, anyway, so next we have the yeah, Z490 Creator 10G. This thing is cool for the same reason that the formula is cool, except it's cooler because it's cheaper. $300 and you get 10 gig. I'm pretty sure this is the cheapest way to get 10 gig. Unfortunately, it's also the only networking this board comes with. So that's the one downside is if you wanted. Wait, what? Asus, what the hell happened to your website? Why can't I go to the gallery? There we go. Um, so I guess they have Thunderbolt as well. You have your like I wish there was dual LAN on this, but like I assume if you're buying the board for 10G, then you're buying it to use the bloody 10G. Also, what's this? That looks like another... Wait a minute. Is that a 10G card and the board itself has a 2.5 gig? Let's go through the overview. This looks like a cool board, and I'm assuming this actually looks like the same VRM that they have like on the Dash E. Yes, that does look like the same VRM that they have on the Dash E. So I'd kind of say, like, I'm not getting. Well, do they keep the postcode? No, there's no postcode. If this still had the postcode, I would be like, I'm not sure why you would get the Dash E instead of this. Oh, I guess this also doesn't have something like BIOS flashback. Yeah, so it has Thunderbolt. It has the 10, so onboard is 2.5 gig, and then they have a 10 gig add-in card. I'm not a fan of having 10 gig as an add-in card. Like, I think it's because the thing is, like, I'd assume you like if you're like a lot of people that buy, I guess, sort of like the thing is, I don't build real workstations, but I've talked to people who build real workstations, and they love having PCIe slots for activities. And having a 10 gig card that is a PCIe card means you now have one less PCIe slot for activities. So that would make that I would assume that doesn't make them particularly happy. At the same time, this is a $300 board with with 10 gig. Even if the 10 gig implementation isn't, like, even if it is going to take up a PCIe slot, like, it has 10 gig, right? Like, just the fact that there's 10 gig at all is a win. So that makes this board really, really cool. In terms of the VRM heatsink, like, a lot of people might say, oh, that looks really, like, industrial, and it's like, well, sure, but it doesn't actually look like it has that much surface area. Like, honestly, I think they could have kept the ROG heatsinks, though it's really hard to judge. Like, the thing is, they've gone out of their way to make that heatsink not look like a heatsink, in my opinion. They've gone really far to try and make it look like a black block. So it's, yeah, like, I'm not gonna judge it too hard. At the same time, the VRM under that heatsink should be, plenty powerful, so I wouldn't be too worried about this. So yeah, this looks like a very, very capable board. Wait, they have only one 8-pin on this. I guess they really don't intend for you to overclock on it, but okay, that is actually like like that I do consider an issue. It is a solid pin, power 10 pin. I mean 8 pin. But the thing is, like, the other consideration as you get closer to the maximum power handling capacity of a power connector, one of the other concerns you run into is that, let's say you put the let's say you don't plug in the power connector properly, or there's corrosion on something somewhere, right? Or like, I don't know, it's really dusty and the dust gets in the way of making contact. Now the power handling capacity of that power connector is lower than what it's actually rated for. So you kind of want to have some overhead. Especially if you're going to be doing like long renders or something. At the same time, like, if you're building a rendering workstation, a 10900K doesn't really make any sense for that. So I guess it's a reasonable decision not to bother with having, like, the thing is, though, the VRM could totally do if they added an extra 4-pin. Like, the VRM could do it if there was an extra 4-pin. And also with how their power plane is laid out, wonder if we can get a better photo of this. Oh, there we go. Like, so, okay, I can kind of see how you might not have enough space to get an extra 4-pin over there because there's like a standoff, like there's the standoff hole is right there. But their power plane goes along like this. They could have stuck a 4-pin up in this area, right? Like where this MOSFET is, they could have stuck a 4-pin there before the MOSFET. Like, I've shifted the capacitor over, or shifted the capacitor to the right, and then jammed a 4-pin in between the two. They would have also probably needed another input filtering inductor, but they could. I'm pretty sure they could have found the space for that. The funny thing is, if you look at ITX boards, they don't actually have input filtering inductors at all. Like, there's just not enough space on those PCBs to have input filters for vCore, so they just don't bother. Like, they have capacitors, but they don't have the inductors for it. Which I don't think that does that much, because, like, if you look at a lot of low-end boards, they also don't bother with input filtering inductors. It's like one of the things that gets very quickly removed is like input filtering for 12 volts. I guess though that maybe like you might have it might make it more like easier for the CPU to trip OCP on your power supply if you're really borderline in terms of your power delivery. But yeah, like so the 10 gig on this is really cool. I really wish it had more power connectors because 10900Ks are thirsty CPUs. But at the same time, I totally understand that like it's not meant for overclockers. And people who like like the thing. I'm not this motherboard's target audience, so it's really hard for me to judge it. Accurate like judge it in a realistic scenario. Because I would totally run a 5.1 gigahertz 900K on or a 5 plus gigahertz 10900K on a workstation. That again I'd assume most professionals wouldn't. So yeah, but cool feature set and at a very like 10G at $300 is actually really competitive. So I'm like that. That's one of the boards that impresses me. It's not a board I would necessarily like. I'm not gonna test that board because it's not within sort of my comprehension of what a motherboard is supposed to do. If that makes sense. Let's move on. Z490-A. Oh boy, we're at an hour already. And this is like a Z490-A ROG, but without the ROG branding. Yep, that's exactly what it is. Different VRM heatsinks. These still look like they have plenty of surface area. Like, I see no issues here. So, same memory overclocking, I'm gonna assume. Oh, no, they're not saying. No, 4600, yes. So this is like a Dash A, but not a Dash A. Right, so Z490-A. This is slightly cheaper. So what did they change? Right, that's always the question with the Asus boards. So what happened that this gets to be cheaper? Oh, I guess they removed the BIOS stuff, like flashback or something. Yeah, so the Dash H gets BIOS flashback. This doesn't. Oh, of course this doesn't. Okay, well, that's not surprising. I guess it gets more USB ports or something as compensation. Yeah, that is what it gets. So some extra USB ports, but you lose the BIOS flashback capability. Um, An SoC heatsink? The hell? There's no SoC VRM on Z490. Like, that's not an Intel thing. We have power stages. We have 8 plus 4 pin power connector. Yeah, see, like, this is just a solid board. This is like a Dash A, but without the ROG stuff. So, which makes sense, right? Like, it's literally called Z490-A, Z490-A Gaming. And there's not really much. Wait a minute. I just noticed something. Let's just go to Newegg's website since I'm already here. Oh, that's just like some fan header indicator thing. So yeah, this adds BIOS flashback functionality to the USB port setup. So to the rear I/O. So that's all it really does. Well, that's neat. So okay, Dash A. Moving on. Apex. Oh boy, this is the most like this is the board I'm most excited for. This thing's so cool, so very cool. So 16 power stages, like monster. I'm gonna assume it's another 7 plus one phase monstrosity. Actually, no. They ditched the iGPU, didn't they? There's no display outputs on this. Yeah, they ditched the iGPU. So this is all 8 phases just for vCore. And the cool thing about doing that is it also like gives you the freedom. Like, if you have a motherboard with an iGPU phase, essentially you need to have some way to get that power from that iGPU phase to the CPU socket, which means you need to have an iGPU power plane. But if you ditch the iGPU phase, you can just kind of go where you can have a much different power plane layout, which I have a suspicion that actually has some benefits for transient response. So this is one of the main reasons. Like that's why I'm so annoyed that I didn't get to test the Maximus 11 Apex, because that one actually has no iGPU VRM, and it's just like I wonder how much that did for transient response. So I'm really like I really want to test this because Yeah, this just looks like an absolute beast in terms of so many things, like the power delivery, which it is only on the 70 amp smart power stages, but I did mention earlier, like 70 amp smart power stages and 90 amp smart power stages don't really have that much of a difference between them in terms of efficiency. You're not going to max out a 16 70 amp power stage VRM. You're not going to max out a 16 power stage 90 amp, 16 90 amp power stages either. Like, it's like there's no functional, like the difference between them is not really practical. Um, so yeah, I'm super excited for this board. And then of course we got the DyeSense, which I already talked about. That that's pretty neat. Um, this I assume still has that terrible graphic. Of course it does. Okay, like but this is a beast of a board. I will say the weird cutout with the SATA ports being all funky. I am not a fan of that. That just like why just make the board square. Like most of it's square anyways, right? Like this cutout over here is like you've taken off like how like 5 millimeters maybe to get that, and it's just like what does it do? Nothing. But yeah. The thing is just, and I don't think they mention it anywhere really, do they? Wait, let's see. Cooling, no. Q code, yeah, they do not talk about just the amazing LN2 features they have, like the RSVD switches. If you don't want to learn your voltages, RSVD switches are super cool. Also, the memory power delivery on this thing is there is so many capacitors in the memory power delivery on this board, and I think the Z390 Gene is kind of the same situation. So yeah, the memory power delivery on this thing looks insane. I like this is a board that I so want to test. Like I have to have one of these. Oh, they do mention say overclockers toolkit. So you have QLED, so you've got your post code, you've got your LN2 mode, you've got your slow mode switch, your pause switch. This is cool for like you can stop a benchmark. Like if you're running a 3D mark or something, you can stall out the benchmark on a loading screen, and if you have an OC panel, you can tweak a bunch of overclock, like you can tweak a bunch of settings, then unpause, and now it'll be running the same thing with different settings. So you could run like, if you're running like Vantage or something, you could run the graphics tests at a higher CPU frequency than the physics test, because the physics test in Vantage hit like is really heavy. So yeah, this is cool. Though I wonder if they're going to be shipping it with an OC panel. Like I actually like the OC panel. I know most of the coverage of OC, like the ROG OC panels in from other YouTubers has been, oh, this is like a stupid gimmick. I like it. I really like it. It's a really cool feature. Then of course we have the retry button. Yeah, like great for memory training, great for recovering when you crash the CPU so hard that the reset button doesn't work anymore. Safe boot button, best button ever created, best button to ever be put on a motherboard. Though it is worth noting, MSI actually offers similar functionality on some of their lower cost boards as well. So I'm not sure. I don't think this is the only board with safe boot from ASUS, but well, actually, even if it was on the Hero's $400, so you'd still be paying $400. So I think there might be some other like boards that are cheaper with similar functionality to safe boot, and those would be really cool to get. Actually, I think the EVGA Z490 FTW has a safe boot button, and I'm not sure how much that'll cost, but if it costs less than this, then well, there's more to it than having a safe boot button, right? Like having a safe boot button is great. Having good memory overclocking support in the first place is better, right? Like this is one of those things. Is like after you already have a great board, one of the ways you can make it greater is add a safe boot button. Then we have the voltage read points, which are hooked up to the DyeSense, which is cool. Well, the V-core is hooked up to the DyeSense, which is cool. Full speed mode switch. What does that do? 4 LEDs to what? 8. Where's 8? Eh? 4 LED current boot state. I am very confused. BIOS switch, so it has dual BIOS, which I've already shared my thoughts on how much I like dual BIOS plenty in the past. So yeah, I love this freaking board. I must have this freaking board. There is nothing is going to stop me from owning one of these, except maybe if, well, let's just leave it at nothing. I'm gonna have one of these because it is such a cool board. Um, Oh, and for Windows XP support, because there's a bunch of like old benchmarks that are like people are very like the I'm not competitive in Super Pi. Okay, like I think I respect massively the people who are competitive in Super Pi, 32 million. I am not competitive in Super Pi. Installing Windows XP to run, and actually I think W Prime, like there's a couple benchmarks that basically just run way faster on Windows XP than they run on any other operating system. That's legal for benchmarking. Like I don't know, maybe you could get Linux to run it faster, but Linux isn't legal because like I don't make the rules. But for competitive overclocking, Windows XP is. And for Windows XP support, having the PS2 ports, makes that a lot easier. Because normally, like the biggest issue is the USB, like getting USB drivers that work for Windows XP with modern motherboards is like, nope. That's apparently a really massive hassle. So yeah, the workaround, just have PS2 ports for that. So this is a board that is just so very cool. Um, that I like. I really want one of these. And I'm really glad that like it's the same price as the Hero, right? Like, which I expected because this board, like, it's not an 8-layer PCB, it's a 6-layer. It's not on the 90 amp power stages, is on the 70s because the 90s don't actually really do much of anything. Um, at least within, well, for really high power consumption, the 90s actually have an advantage. But in the sort of power draw ranges where you'll be seeing a 10900K, they don't do anything. Um, so yeah, this board I'm super excited for. I'm super excited for this board. Anyway, moving on, we've got the 12 Hero. I need to check the time. It's 11 o'clock. That's fine. Um, so does this have safe boot? Of course, does this have safe boot, right? Like, what else would you be interested in? 4666. So I guess this is on a. Wait, so is this like a mid-step memory layout? Oh no, this has better memory power delivery. So I guess they're like, okay, so I guess the 66 megahertz more from better power delivery than in better memory topology, which is what you get with the formula. You get 4800. By not having unnecessary DIMM slots, the Apex can do 5000 on a 6-layer PCB. Um, like, yeah, this is so the Hero, like the thing is VRMs way up there again. This is, I do believe, a 14 plus 2, which is fine because the 16, like, if you want to have working quick sync, you need an iGPU VRM. There's not really anything you can do about that. Um, I assume this still has the die sense. Please have the die sense. Why do I not see mention of the die? Oh, there it is. Yeah, so accurate voltage monitoring. So this is really cool. Um, yeah, like here's the thing for Z490, like we're in the same situation as X570. I feel like around the 400 price, around the $400 price tag, where it's like you have the Hero, you have the Master, you have the Ace from MSI, and it's just like these are all very solid motherboards, and they all cost about the same. So go and pick your own poison. Um, yeah, like because the thing is, I'm not actually going to test all three of them. I have a Master, but there's just like I have no interest in going out and buying a Hero to test it. But looking at the Hero, I just don't see anything wrong with this board. So I like if you buy one of these, I'd be very surprised if you were disappointed. Um, I don't think you need a $400 board. Like there, as I've mentioned, like there's some very solid options all the way down to around like $200, right? But if you want lots of features, I wish we had a gallery for this one. Like this is stacked in the rear I/O. I wonder if Newegg maybe has better pictures. Like, cause this is, I do believe it has dual LAN, which of course is nice to have. Yeah. So well, you can just, well, can you? No, you can't really tell. So, man, why, why can't we see the rear I/O? Like you'd think they want to show that off, right? Yeah, but there's no gallery page for the board, unfortunately. But Hero's definitely like that looks really solid. This makes the, like, I think going from the, like, so Z490 compared to, like, all the Z490 motherboards compared to their Z390 predecessors, there's a lot of big upgrades. But I think the biggest upgrade is going from the, like, in terms of the motherboard, the biggest difference is the Maximus 11 Hero versus the Maximus 12 Hero. This thing is just so much better. Mainly in the power delivery. I don't think, like, the feature set, actually, I think also got an update with this, but I don't remember the feature set of the Z390 board at all, because I was just like, well, I didn't like the Z391 very much. But yeah, this is a cool board. And now we have the Maximus 12 Extreme. Wait, so that's interesting. Here they claim 4,700, whereas I'm pretty sure on the formula they claimed 4,800. How does that work? Because I have assumed these both use the same topology. 4,800. 4,800. Oh, I guess their front page is just behind their specs page. Okay, well, whatever. So this has 10 gig, 2.5 gig, of course, you know. Unfortunately, no gallery page. This has the same power delivery for the memory as the Apex, with the ridiculous configuration of aluminum polymer capacitors, which, yeah, you can see all of those rectangles over there. I think actually the formula might have that too. It's actually, you can't see it because they have the stupid plastic shield over it. That's actually really disappointing. Yeah, we can't see the memory power delivery on this. Actually, I don't think they have enough space for it. Because, like, those caps, well, I guess they could be on the back. Like, you could put them on the back. And at the same time, having to go through vias, I'm not sure how that would affect their effectiveness. But, yeah, anyway, so the power delivery for the memory on this is basically, like, it's the same power delivery you get on the Apex, except now it's powering 4 DIMM slots instead of 2. So there's obviously a bit of a loss because you're going from 2 DIMM slots to 4, but they've compensated for that with, the higher layer count. Then I think this is on 90 amp smart power stages. Like, this is a very, very nice board. And I actually liked even the Z390 Extreme quite a bit. Like, that was one of those boards where I was like, I wish I had a chance to test it. Because, yeah, it's just like, if you actually want higher memory capacity support, this is it. This is the best thing you can get from ASUS with 4 DIMM slots. Now, also, it has an absolutely ridiculous price tag, right? We can't forget that is a $750 motherboard. But this is the thing. I feel like there's a lot of really expensive Z490 boards, and it's just like, but they are really nice. Like, they're really nice, and I wouldn't, like, you don't need one of these. Like, please, like, as much as I love what they've done with the board, I am not saying you should buy one of these. I think most people should be buying something like the Dash G, or the Tough, or the Dash H, or, like, I think most people should be buying sub $300 motherboards up to, the Dash E, because the Dash E adds a postcode, and postcodes are very nice to have. And then once you start going above that, it's like, like the Hero, I don't know. Like, I feel like if you're really into overclocking, the Hero doesn't do that. Like, the Hero isn't that much of a step up from something like the Dash E. Well, I guess you get the DyeSense. And I think it has, like, the rear I/O on this is better. So, like, I'm not sure. But, like, basically there's a lot, like, there's not really any motherboards that I can point to and go like, oh, this is a massive disappointment, because there isn't one. I mean, these are, if you're running a 6-core or an 8-core, I mean, 8-core is going to be, you're going to have to run some airflow, but 6-core, they're going to be fine. And then once you go above that, you just get, steadily, like, nicer boards, and they're all very, very nice to start with, right? So yeah, I'm going to test, like, that's why I'm interested in testing the Dash G and the Apex. And I think what they've done with the formula for Z490 is really cool. What they've done with the Extreme is really cool. But those are also $500 and $750 boards, and there's just no way I'm buying those to test them, right? Like, That's the main thing. Is I do actually have to buy ASUS boards, which means I won't get to like I'd really like to test a like 4x8 memory overclock on this. Because this is a because I assume, well, yeah, I like to test like 4x8 on this because that I think would be interesting to see where it goes. At the same time, 4x8 4x8, well, the thing is just like this board like the problem I'm having is the extreme adds also a lot of the extreme overclocking features that you get on the Apex. Like I think you get some of the RSVD switches. Um, oh wait, they do show the rear I/O. Yeah, so this has 10 gig and 2.5 gig. Um, no Thunderbolt though, really? I would have expected it at this kind of price tag, but well, whatever. I don't really care that much. I'm trying to find if they ever mention because they have all of the like you can see it over here, right? You have the voltage read points, power button, reset flex key button, which I assume is like a rebindable reset button. I hope this also has dual BIOS. Yeah, there's a BIOS switch down there. Like this looks like they basically took an Apex, stretched it out, added 2 layers, and added 2 DIMM slots, and then replaced the power stages. That's what this looks like. And of course, I like that because I like the Apex. Oh, and then it has a bajillion fan headers as well, I guess. That's another thing that they've done with this board. Um, yeah, like so this is an interesting board. It also has the little extra capacitors in the socket and on the back of the socket. I've actually gotten a picture of the back of an Apex at this point, so yeah, there's like this is why I'm so excited for Z490. We're just seeing some really sick boards. Unfortunately, they're also at really like insane prices, but like the thing is like with the flagship motherboards, I feel like, well, these aren't really meant for most people. You don't need an extreme, as cool as I think it is. You're not gonna, it's not gonna be a game-changing difference if you go with a Dash G instead, or a Dash A. Well, yeah, it's not gonna be like a game-changing difference. The extreme would be interesting. Like I'd like to see what the extreme can do with 4 DIMMs on LN2. Like that's the main interest I'd have in it, because if you're gonna go for 2 DIMMs, the Apex is gonna run right, or like is gonna just run circles around it, because if you don't have the extra DIMM slots, that's just such a massive advantage. Um, but yeah, other than that, it's a really cool board. And then even like the Formula, I think, is a cool board. So yeah. So where ASRock was just like one steadily increasing disappointment when I did the just, walking through their boards, ASUS has me really impressed. Basically from $200 up, there's motherboards that are good. And then they just keep getting better and better as soon as you like for normal people, 10900K, stick it in a Dash E if you want the postcode. If you don't want the postcode, you can just kind of stick it in anything that has enough USB ports or enough SATA, like whatever it is you're looking for, right? Like you might need USB ports, you might need networking. You have plenty of options, and those options get as cheap as $200. They get as expensive as $300. And then if you're really like overclocking, then you've got your heroes, your apexes, your formulas. I feel like if I was going for a 4-DIMM Asus motherboard, I'd actually go for the formula instead of the hero, just because this does seem to have a extra, like this has a different memory layout. So, yeah, for that reason alone, I would go I'm pretty sure that's an 8-layer PCB. So for that reason alone, I would go from the hero to the formula. Unless I just want to make sure, because I'm pretty I just want to make absolutely certain I'm not wrong about that, because we did notice with the Extreme that the Extreme's front page was like, oh, 4700, and then you go to the specs and it says 4800. I don't know if they did that for, oh, they also do 4800. Wait a minute. Now I need to check more of them. So actually, the Hero is also solid. So the formula if you want the 10 gig, the Hero if you just want the best 4-dim overclocking that Asus has to offer, I guess. Like, I wish they would just say how many layers they have. Yeah, no, they doesn't say. Because it would just make it so much easier to track which memory setup you have on which boards. Right? Like, I don't really consider, like, I wouldn't compare a 6-layer Gigabyte to a 6-layer Asus because that's, you don't know. You just don't know. Maybe, or I wouldn't compare a 6-layer ASRock. Like, I wouldn't compare layer counts between board vendors, but within a board vendor's own product stack, it's a pretty good way to track which motherboards share memory designs, right? And so it's useful for that. So I don't get why the front page is like 4666. Are they sandbagging the front page for their motherboards so that they like get people to buy upwards? Because it's like the specs say 4800 for both of them. And I know for a fact that with like a good like for Z490 4800 with a good daisy chain and the right memory kit is very very doable. So I don't find these unrealistic memory speeds whatsoever. But yeah. The one thing the Hero does lack that the formula adds is the little in-socket capacitors. The Hero doesn't have those. And then of course it lacks the 10 Gs. But yeah, basically like if you're into overclocking but you also need 32 gigs of RAM, Hero is sort of Asus's solution for you. If you're into overclocking and don't need 32 gigs of RAM, then you can go get an Apex. So the main reason I say don't need 32 gigs of RAM and somebody's like, but you could totally run two 16 gig DIMMs on the Apex. I have very like I am with the extreme overclocking boards. I have like the thing is it's not even the extreme overclocking boards. The problem is 16 gig DIMMs are rare. So the BIOSes don't necessarily work that well with 16 gig DIMMs. Even though there's not anything inherently wrong with a 16 gig DIMM as far as I'm aware at least. The problem is like the motherboards don't know what to do with them. And so when you stick a 16 gig DIMM into a motherboard, a lot of the time it'll actually clock worse than, you know, 4 DIMMs of 8 gigs. Because the board, like, sure, 4 by 8 on a daisy chain isn't optimal from the way the memory layout goes, but at least the BIOS knows how to work with that. Whereas if you have two 16 gig DIMMs, the BIOS is going to go like, well, I have no idea what I'm doing, and it's not going to post at higher frequencies. So, like that's kind of the thing is like 4 by 8 is common compared to 2 by 16, and so 2 by 16 is kind of sketchy in terms of memory support, even though it shouldn't really have a problem. And if you have a motherboard that works well with 16 gig DIMMs, or have a set of 16 gig DIMMs that work well with your motherboard, because that's the other thing is there's, you know, variations of the 16 gig DIMM design depending on which vendor you're looking, which vendor's memory sticks you're using. Like if like basically with 16 gig DIMMs, like it's really hard to get them matched up well with the boards. With 8 gig DIMMs, there's still a lot of variety, but they're so much more common that the board vendors seem to actually optimize for a larger variety of 8 gig DIMMs than for, you know, 16 gig DIMMs. So yeah. So yeah, I overall really like the Z490 Asus motherboard lineup. It's fun. I mean, it's really expensive at the top end, but I think, you know, because the Maximus 11 Hero I think was like $300 to $250, and this, like the Maximus 11 Hero in a lot of like shares a lot of its design with the dash P down here, whereas this doesn't. Okay, like this is like especially like power delivery on the Hero is far more similar to what you get on the Dash P than it is to what you get on the 12 Hero. So yeah, I think the, you know, $100 more for a Hero that now has just like 4 times as much. I pretty much 4 times. What is it? Yeah, because you have better power stages, more power stages. So basically 4 times like 3 to 4 times as much power delivery. And you know, like, also you have to factor in that I assume the board is still designed, like, Asus doesn't advertise it like some of the other vendors, but I assume the board is designed with PC, like, to the PCIe 4.0 specs. And that means, like, because this board has that first 16x slot and then the second 16x slot, it's now like, now you have to have a set of expensive PCIe 4.0 switches and an expensive set of PCIe 4.0 redrivers, and then you also have to have a PCIe 4.0 spec PCB, which is more expensive than a PCIe 3.0 spec PCB. And you know, so it's like, so that costs more. Then of course 2.5 gig LAN versus 1 gig was standard on Z390. Even at $300, I think most of the boards were on 1 gig. And actually, this has a 5 gig and a 1 gig, right? Or no, it just has a... No, it has second LAN. So it has dual LAN. It has 5 gig and 1 gig. Like, you know, like, I consider this reasonable. Well, okay, not reasonable, but justifiable. Or actually, like, I don't know. Like, I guess it depends how long you plan to keep your motherboard, but like, do you really think a 10900K is going to become irrelevant anytime soon? Right? Like, I know some people might be like, but now the 8 cores are taking over, and like, I think I think there's a chance that the 8 core is kind of the sweet spot right now for CPU design, in terms of size. Right? Like, we've been stuck on quad cores for a very long time, and, you know, AMD tried to not do quad cores early on. Remember the FX series? That was like AMD trying to go like, oh yeah, we can do 8 cores for cheap. And then it was like, well, no, you can't. Your cores suck. And so I think there's a good chance that, you know, we might be stuck on, or it's not really stuck, like, we'll just be seeing a lot of sort of 8 core being optimal for a while now. So if you have a 10 core, it's just like, well, it's not going to be irrelevant next year. I'd be very surprised if it was. So, you know, and then the other thing is, like you don't need upgrades every year, right? Like, yeah, if you're gonna buy a new motherboard every year, then buying a $400 board and then another $400 board is less cost effective than buying a $200 board. At the same time, if you buy your $400 board and then don't change motherboards for the next 5 years or something, then you might want to start with a really nice board. So, you know, you have as many USB, like, maybe right now you don't use that much USB, but in the future you might, and then it's like, oh, now I need a different board. Well, you know, like, that's the thing, is like, you don't need to upgrade every time Intel changes the socket, because newsflash, Intel would rather go bankrupt than stop changing sockets every 2 generations, right? So yeah, anyway, I think these are cool boards. I think Asus, with their Z490 motherboards, they have some very impressive boards. Yeah, that's it for this video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me. There's a link to that down in the description below. That will, you know, make my life easier when it comes to buying the various Asus motherboards. Who knows? Maybe if enough people use the Patreon, I'll buy an Extreme, but I kind of doubt that'll happen. Because that's a $750 board. So, you know, it's just like, yeah, that's probably not very likely. But yeah, so there's the Patreon. There's a link to that down in the description. And then there's also the AHOC Teespring store, which achieves exactly the same thing as the Patreon does, except you also get like a shirt or stickers or a poster or whatever in return, because Teespring is for YouTuber merch. So yeah, you can check out the link for that down in the description below as well. And that is it for the video. So thank you for watching, and goodbye.